Hello again. We are going to start Unit 5 today. This is the first lesson in Unit 5 on sets. So let's get started. We're going to make a few definitions because it is the first lesson of the unit. So we'll start by saying that a set is just a collection of numbers or objects. Those objects are called elements or members of the set. And if X is an element of the set P, then we write X is an element of, that funky E means is an element of the set P. Okay. If a set has nothing in it, then we call that the empty set, and it's notated by a set of brace brackets with nothing between, or a zero with a line through it, and that just means it has no elements in it. Okay. A finite set means that you can count the number of members or elements in it, and an infinite set means that you can't because there's infinitely many. Okay, there are some commonly used sets of numbers that we've already talked about in the very first unit of this course. There's natural numbers, 0, 1, 2, 3, and so on. Integers, which includes positive and negatives, but no decimals. We've got the positive integers, 1, 2, 3, and 4. We've got the negative integers, -1, -2, -3, -4, and so on. We've got the rational numbers, which we write that as the set of P over Q, where P and Q are integers and Q cannot equal 0. And then we've got the real numbers. That's any number that you can plot on a real number line, so I'm not going to list those. There's way too many of those. And then we talk about subsets. A subset is just some smaller part of an original set. So it has some of the elements of a bigger set. It may even have all of them, but it definitely has some of them, and it doesn't have any that are outside of the original set. Okay, and a proper subset would mean that it definitely doesn't have all of the original elements, but it doesn't have any new ones either. Okay. So if I had, for example, set P having numbers 2, 3, and 5, and Q having numbers 1, 2, 3, 5, and 6, then P is a proper subset of Q. It has some of the elements of Q, but not all of them, and it doesn't have any elements that Q doesn't have. Okay. Now let's talk about unions and intersections of sets. So P and Q are going to be two sets. The union is going to be written as P with a little u and then Q. And that's the set of elements that are either in P, or they're in Q, or they're in both. And we'll only list each one once, even if it appears in both sets. And then the intersection is going to be written as P with an upside down U, and then Q, and that's the set, that is the set of elements that are in both P and Q. So it's kind of like the overlap of those two sets. And so if two sets don't have any elements in common, we call that being disjoint or mutually exclusive. So let's talk through some examples. We've got set P, which has the numbers 1, 2, and 4. We've got the set Q, which has numbers 1, 3, and 4. So the union of those sets, P union Q, is the numbers 1, 2, 3, and 4, because those numbers belong to either P, or they belong to Q, or they belong to both. And then the intersection with P upside down U, Q, that's the numbers that belong in both P and Q, and those are just the numbers 1 and 4. Okay, another example with a different P and Q. If P has elements 5, 7, and 9, Q has elements 6 and 8, then the union of those two is the set of numbers 5, 6, 7, 8, and 9. And the intersection is the null set because there are no common elements between them. And in fact, that's a case where P and Q would be disjoint. So that is kind of an overview of sets in the first lesson. If you have any questions, let me know, and I will see you tomorrow.